Hi everyone, this is Lavit, Raster Terrain Analysis. In task 1, we need to perform a local operation on a grid using a scalar. In step 1, launch ArcGIS Pro and rename the map frame to task 1. So right click the map frame and then go to properties and rename it to task 1 and then click OK. In step 2, in the catalog pane, navigate to Lavit where you have the downloaded folder and then add PLNE to the contents pane. So right click PLNE and then add to current map. In step 3, right click PLNE and then go to properties. Then go to the source tab and examine the raster properties. You can see the various information such as columns, rows, number of bands, cell size, pixel type, pixel depth. And then you can answer question number 1, which says how many cells are there in the raster if you would multiply the number of columns by the number of rows. So you have the number of columns and you also have the number of rows. So you multiply them and then write your answer for question number 1. Step number 4 says right click PLNE. So let us do that and then go to symbology. Next, click on Marks tab in the bottom section of the symbology pane and then click the drop down next to node data field and select a color to display the node data value. Example, you can use the red color. Step 5, right click on the PLNE grid and then open the attribute table for it. The table will show you the count for the each elevation value of the cell, and you can right click the count column, then go to statistics. It says that the total number of cells is 142005, and then you can answer question number 2, which says how come this number is different than the one for question number 1. So you can see that we have the border which is representing the red colors with no data value. So the presence of no data cells are also responsible for this. So we are getting a different result than the one for question number 1. In question number 1, we calculated the total number of cells by multiplying the number of columns by the number of rows, and then use this understanding of these red color borders to answer question number 2. And question number 3 says how many cells carry a no data value in the PLNE grid. For that, you can subtract the count of cells with valid elevation values from the total number of cells in the raster and use your answers from question number 1 and question number 2 to help you answer question number 3. And then in step 6, it says hide no data cells by selecting no color for no data cells again. So for that, let us go to the symbology for the PLNE raster and then go to marks, and here select no color. And in step 7, in the ribbon, click on Analysis tab, and in the Geoprocessing group, click on Environments. In the Environments dialog box, if the current workspace or the scratch workspace is not your Lavit folder, then you can change it to Lavit folder. But for me, the current workspace as well as scratch workspace are both lavette folder, so I don't have to do anything. If that's not the case, you need to change it to lavette and then click OK. Now you will convert the elevation values from meters to feet. For that, in step 8, click on Analysis tab, and in the Geoprocessing group, click on Tools and then search for Raster Calculator. And then enter the formula PLNE multiply by 3.28, and you can save the output raster as PLNE feet. And click Run. The new raster PLNE feet shows the elevation in feet instead of meters that we had earlier. And then in step 9, go back to raster calculator and now enter PLNE feet greater than or equal to 3000 and save the raster as PLNE 3000 in step 10. And then click Run. You can observe that the cells that have the value of 1 in the output raster PLNE 3000 meet the specified criterion, and the ones that have the value of 0 do not meet such criterion. For screenshot 1, make all the cells of value 1 red. So make red for 1 and then make all the cells of value 0 white. So let us make it white by right clicking on the symbol and then selecting white color for 0, and then take a screenshot of PLNE 3000 layer with the symbology and then put it in your Word document. So you can take a screenshot of this, and then after that we can next count the number of cells with value 1 in PLNE 3000 and then subsequently calculate the total area of PLNE above 3000 feet. So in step 11, open the attribute table of PLNE 3000. You can observe that the number of cells with elevation above 3000 feet is 72953. And then in step 12, go to the properties of the PLNE 3000 grid. So right click PLNE 3000, go to its properties, and then under source, go to raster information, and you can observe that the cell size is still in meters, though we converted everything to feet. And the cell size here is 30 into 30, which is 900 square meter. Therefore, the total area of PLNE above 3000 feet would be equal to count of the cells that meet the criterion multiplied by the cell size, and then we can get the total area of PLNE above 3000 feet. And then question number 4 says, what area of PLNE has elevation between 4000 feet and 5000 feet? And we should also include both 4000 and 5000 feet. For that, you can go to raster calculator again, and then in the expression, you can type PLNE feet greater than or equal to 4000. Also remember to use the brackets, parentheses here when you are writing the expression, and then enter the expression and again PLNE feet is less than or equal to 5000, and then you can give the output raster the name and then run it. And then in order to answer the question, you need to first open the attribute table for the obtained raster. If you look at the attribute table, you can see that the cells from count field in the attribute table that meet the criteria are 26390 in total. So there are total of this much cells that meet this condition. And then also go to the properties for this obtained raster, and then go to the source tab and go to raster information, and you can observe the cell size, which is 30 into 30, which is 900 square meters. So you need to multiply the cells that meet the criteria, which is 26390, with the cell size that you get from the layer properties for this, and then you can answer the question. And this is all for the task 1 of lab 8. Thank you.